now we're going to want to work on the pipes. The pipes are another essential piece to Flappy Bird. In Flappy Bird, if you hit a pipe, it's game over. You need to be able to maneuver the bird directly in between the pipe, and this is why Flappy Bird was so popular for a while, is because it was so incredibly infuriating to do that. So, but in this case, I'm going to use the green pipe. We can drag the green pipe right into our assets. Now in Flappy Bird, you can see right here, we only have one pipe, but in Flappy Bird, there's two pipes that are stacked on top of each other. We're going to do that in Unity, just so we can have a bit more headroom when we continue working on the game. So I'll drag it in here, and what we're actually going to do is we're going to not want to directly work off of this, we're going to create an empty. This is going to create an empty game object. I'll name it pipe, and this is where all of our pipes stuff is actually going to go. So we can drag our green pipe into the pipe, and I'm just going to reset the transform so that way it's directly in the middle. So now I'm just going to drag the pipe down. I'm going to hold control so it kind of snaps to the grid just so it's easier to move around, and I'm going to duplicate the green pipe, and I'm just going to move this up. If you want to move it an equal distance away, the bottom pipe's at y level negative 2.25, so if we want it to be equal distance, you can set the y to positive version of that, so it would be positive 2.25. Now they're kind of looking the wrong direction, so what we're going to want to do is we're going to want to take the scale tool and drag this little green guy down, and that'll flip it, and it should match the size. The reason we don't want to, we could rotate it to get the effect we want. However, you'll notice that the light kind of contradicts itself here. The light's shining on the front of the green pipe here and on the back of the green pipe there. We just don't want that, so I'm just gonna move this back. And if you want, I'm holding control while I scale this as well, so it makes it so that the pipe is the exact same size, because we don't want the size to change. Now the pipes are kind of small, so what we can do is we can click on the empty game object that's actually holding the pipes together, and with our scale tool selected, we can drag the middle white block, this little white block in the middle, and we can scale that up. Now the pipes are actually really far apart, so I'm just going to move them around to get a more desirable effect. So let's say we'll go with this. I'm currently putting both of the pipes on 2, so top one's at y level 2 and the bottom one's on y level negative 2. So now we're going to need to position the pipe where we think we need it. So in this case, I'm going to drag it off the screen so we don't see it when it spawns in. So we'll say at x level 11. X position 11 is where the pipes are going to be. Now what we need to do is we need the pipe to spawn at a random y level, because we can't just have the pipe in the middle the entire time. That's just not going to be very fun. So we're going to create a flow graph for this. Actually, before we do that, we need to create some box colliders for these so the bird can actually hit it. So on the green pipe, both of the green pipes, we can just go add component, look up box collider, and we want box collider 2D, and it'll create this box collider perfectly around our pipe. We can always change this later if we want using the little edit collider button down there, but for now, I'll leave that be. So now, we're going to go to the pipe object, we're going to hit add component, we're going to go out of this, go to bolt, and then click flow machine. Create a new macro, I'll call it pipe movement. This is where we'll be calculating all of our pipe movement. So in this case, we're going to want to use the start event here, because we want, at the start of the pipe's life, I guess, we want it to immediately change its Y position to something random. So we'll drag this out, and we're going to want to set the position of the pipe. So in this case, we can look up transform, and then I'll type in position. So transform set position right here. Now, we could type in the position we want right in this box. However, this only really works if you have a set position every single time, which in this case we don't. We have the pipe constantly changing Y positions every time it spawns in. So in this case, we're going to want to have a vector 3 coming into this. So in this case, we can drag this out. We can type in vector 3, and we can see at the top here, there's this vector 3 tab. We'll click it, and then we're going to want create vector 3. Now we got this little vector 3 component with all the x, y, and z coordinates completely separated. So in the case for x, we can just type in 11 because that's where we want it to spawn every single time. In the case for y, this is where we're going to want it to randomize. And we don't need to worry about the z-axis because that does not matter in 2D, at least for position-wise. So for the y coordinate, we're going to drag this out, and we're going to look up random. We're going to want to use this random range block. Now you can see there's 2 of them. This is because if we look at the bottom one here uses integer inputs, whereas the top one uses float inputs. A float is a number value, but it can use decimal points. An integer cannot use decimal points. It only works in whole numbers. It's good for saving space, but it's not necessary for here, or at least for here, we're going to want the decimal places. So we're going to use the random range block that requires the float inputs. So you can see it's plugged into the y, and we're going to want to put a minimum value and a maximum value. So if you go back to our scene, we can kind of move these around to see where we think we want the pipes to go. So in this case, if this is how high it is, 2.65, how low it is will just be that, but it'll be the negative version. So instead of it being 2.65, it'll be negative 2.65. So in our flow graph, in the random range, in minimum, we're going to type in negative 2.65, and in the maximum, we're going to type in 2.65. So now we'll see, if we go to our scene and stare at our pipes here, if I click the play button, you'll see the pipes set a random y coordinate. And if we play it again, it should choose a different coordinate. You can see it moved up slightly that time. So this is the effect that we are looking for. Now, we need to get the pipe to move from the right side to the left side of the viewport. In this case, we can do this in code. We can do this in the update event. So we want to change the transform. So we can look up transform position. In this case, we want to do set position. Drag the update into there. By the way, you can right click to add unit. You can do that as well. You don't have to drag out the wires. So now we're going to want to do the same thing we did here, where we grab the vector 3 create here. In this case, we can just actually copy and paste some of these components. We don't actually need to add one every single time. If you hold Control C, you can copy components, and if you hit Control V, you can paste components. So in this case, I'll set X to 0 for now. Y, we'll have to change. So X and Y, we're going to need to change through code. So X, we're going to update. Every frame, we're going to update it by a fixed amount. Y, on the other hand, we're going to need to set it to whatever this value up here ends up being. To change its X coordinate, we're actually going to create a variable. Go to the variables component, right at the pipes thing, and I'm going to type speed. I'll add it, and then under type, I'm just going to click float for now because I don't know if I'm going to need to change it by any decimal points. So now we've created a variable. This is the exact same thing as going in a C# script and typing float and then a name. It's just creating a variable. So now we're going to set this variable to whatever value. You can set it down here. For now, I'll set it to 0.5. So now we're just going to plug this value in to X. However, we can't just plug this value in because we're going to need to be changing this X by whatever our speed value is. So in this case, we're going to right click, we're going to add a unit, and we're going to, first we need to get our pipe's X value. So if we want to get our object's X position, we need to right click, add unit, and we're going to look up transform position again, and we're going to click this first option, get position. Now we can drag out this little dot here, and under the vector 3 tab at the top, we're going to want to scroll down, and you can see it's 3 options: get X, get Y, and get Z. In this case, we're going to want to click get X. And now, what this is basically doing is getting the X coordinate in this vector 3 value. So we don't want to plug this right into our vector 3 down here, because that'll essentially just continuously set its x coordinate over to itself, which we don't want. Instead, we're going to want to add our speed value to this. Or in this case, we want to subtract it because the pipes are going from the right side of the screen to the left side. So we can drag this out, and then we can go down here. There's a bunch of math things here, but in this case, we want subtract. Now you can see the subtract component. It takes in two variables and has one output. The first one is A, which is these. The A is going to be our pipe's x coordinate, and the B is going to be our speed. If we want to access our variables, we can right click, add unit, scroll down to the variables tab. We click it, we go to object, and now we can see we have a few objects here. We want to grab the get speed, and this we can plug right into there. Now this output's green. We don't need to worry much about that. They are different colors, but we don't need to worry about that. All you need to know is that it's grabbing our speeds variable and plugging it into the B component. So now, if you know how subtraction works, you can see it right here in the block. It kind of shows you what it's actually doing. So it's taking A and it's taking B away from A. So in this case, it'll be whatever x coordinate is minus 0.5. Now we can drag this into our x. Now this might actually be a bit fast when we test it out, so we can always change it later simply by changing this little variable function right here. So if we go to our scene, I'll scroll out a bit just in case this is fast, but if we hit play, we should see the pipes moving across. Yeah, that is really fast. Alright, so I've brought the speed down all the way to 0.01, and I think this will work pretty well for now. So now that we have the pipe moving across the screen, we're going to want to get the pipe to spawn in every couple seconds. That way we have continuous and infinite gameplay. So in order to do this, we're going to want to create a prefab out of our pipe. To create a prefab, you take your pipe component, and we're just going to drag it to the assets. Now you can see it's highlighted blue. Now what we can actually do is we can just delete it from our scene. It's not going to mess up anything because it's saved right down here. If we ever need it again, we can just drag it back up. Now we're not actually going to add it to the scene. We can delete it because what we're going to want to do is we're going to want to spawn the pipe in. We're going to want to create copies of this through code. So in the hierarchy here, we're going to right click, create empty object, and I'm going to call this pipe spawner. So I'm just going to go to the top right here, and I'm just going to set the icon to green just so we can actually see it, because you cannot see game objects. So I'm just going to set its position to where I put the pipe originally. So hopefully the pipe should spawn right there. So we're going to do exactly what we did before for the other two objects. We're going to go to add component, bolt, flow machine, and then new macro. I'm going to call this macro pipe spawn. So in the graph here, we're actually going to do this under update. However, we can't have the pipe spawn in every single time this update loops, because the update function functions every single frame. So if it's outputting hundreds of frames, it's going to spawn in hundreds of pipes. So we're going to want to create some sort of a timer. Now if we're going to want to make a timer or a loop on a timer, we're going to want to use the update event, in this specific case for bolt. So in this case, I've grabbed some code offline and we are going to translate that into bolt. The code requires two float variables. So we're going to go to the variables, we're going to create one called period, and then we're going to say this is a float, and we're going to type in another one called next action time. Once again, also a float. So what we're going to want to do now is we can change these as we go, but period is going to default to 0.1, and now we do things in our update. So we're going to want to create our branch block again. This is our if block, remember that. Now for our argument here, we're going to want to use one of these operators. We want to look for the greater than operator. Now the greater than operator, if you don't know how this works, takes in two variables, so A and B. and then it checks if A is larger than B. So in this case for A, we're actually going to use a component. I'm going to type in time. We're going to want to use get time. For B, we're going to want to use our variables. So if we drag this out, we can scroll down, click on variables, object, and then we want get next action time. So now what it is doing, oh, what happened here? There we go. So now what it's doing is it's taking A and B and seeing if time is greater than the next action time. So now if this is true, I'm going to go back to our variables, object, and we're going to set next action time. And then down here in our input, we're going to scroll down to math, generic, and we're going to click add. So the two variables we want to plug in here, our top one, we're going to scroll down the variables, we're going to grab our next action time, and then the bottom one, scroll back down the variables, and we are going to grab our period right here. And now we can basically put whatever code we want next to it. So in this case, every time this loops, we're going to want to instantiate our pipe, which means create our pipe. So we're going to type in instantiate. And now you can see when you look up instantiate, there's a lot of different instantiate components. In this case, we're going to want to use the ones labeled game object because that's what we want to create. We want to create a game object, not a component. A game object. A component is one of these over here on the side. Our game object is what our pipe is. So we're going to click game object and we want this third one in the middle because these other ones have other components. In like the first one's case, you can also tell where to spawn in the pipe and how it should be rotated. But in this case, we just want to leave the pipe as is. So we want this one that literally just spawns in the pipe. We're going to take our prefab of our pipe down here, we're going to take it and we're going to drag it into this spot where it says original. That's where we're going to want to drag it in. So now, every time we have this loop, it'll spawn in this pipe. I know this timer was kind of complicated, but if you followed correctly, it should be totally fine. And this period right here is whatever every couple seconds. So in this case, I'll just type in 3 seconds for now. So now every 3 seconds, it should instantiate a pipe. We can hit play to test this out. There we can see pipes are getting spawned in. And every 3 seconds, we're getting a pipe. Now I am noticing our pipes are kind of spawning in at the middle. Why is that? Oh yeah, here it is. Okay. So when I messed up something in our pipe code, at the Y coordinate, it's just continuously setting it to 0, which we don't want. We want to do something like we did over here. So we're going to right click, add component. We're going to look transform. I'm going to click this top tab, get transform literal. I'm going to right click, look up transform. We're going to type in position next to the transform, get position. You can drag this out, click on the vector 3 tab at the top, scroll down to get Y, and then we can plug this right into our Y coordinate. So now if I hit play, it should work totally fine. There we go. Now we're getting a little bit of variety. Now one thing we have to do is we need to make sure our pipes disappear. Because as you can see, these pipes aren't leaving. They're just kind of hanging out. So we're just going to create, in our update tab here, we're going to want to check if our object is past a certain point. So we can say if it hits, let me drag this in just to test this out. But if it hits around here, so we can say if it hits x -11, delete it. So back in our flow graph, we can go to the end of the transform, we can drag this out, and then we can grab another branch block from the control tab. In this case, we're going to want to be checking for a position. So we'll drag this down, we're going to want this one, greater or equal. Essentially, we're going to check if our object's x value, which will go into A, is greater than or equal to whatever value we set to B, which in this case, it'll be -11, because that's the x coordinate we want to check for before we delete the object. So let's right click, add unit. We're going to do the same thing we did before. We're going to look up transform position. We're going to want get position. We can drag this out, go down to the vector 3 tab, scroll down, and then click get x. This get x will plug into the A here. We can drag things around to stay organized. And then in B, we're going to type in -11. Oh, my bad. We're going to want less than or equal. We're going to want to drag this out again. We're going to want less than or equal to. This is because it's going negative. So now we're going to do -11. So if A, our x coordinate, meets or goes lower than -11, it will be deleted. So we just got to get the deletion part made. We can, in this case, we want to go down to our game objects. Once again, we're destroying a game object, not one specific component. Now we're going to want to use a second one here because this first one also takes in another variable to say how many seconds until it gets deleted. So let's drag out true. We're going to look up destroy. Now destroy will destroy essentially whatever we tell it to. So in this case, we're going to want game object destroy because we want to destroy the pipe game object. There's two of them here. We're going to want the second one because the first one also takes in another variable which will say how many seconds until the object will be destroyed. We want the object to be destroyed instantly, so we can just click the second one. Now we do not want to plug in our pipe asset right here because in this case it might delete all the pipes in the scene. So instead we're going to drag this out, and I'm just going to look up self. So now it'll destroy itself once this criteria is met. So if we go back to scene, we can click play. So now we can see the pipe. Once the pipe hits x -11, you can see that the pipe is getting destroyed. And this will just limit the amount of things in the scene at once. And on the screen, it does not look like anything is out of the ordinary. So thanks so much for watching this tutorial. I'll have part 3 out right now. If you build your game, you might notice a little bit of an error where the pipes are super close together and they may be moving very slow. I will go over how to fix that in the next video. Even right now you can see the pipes are moving a little fast. That's just because I've changed the screen size when playing in max mode. So I'll fix all of that in the next tutorial. If you enjoyed, then leave a like. That helps me out a lot and it's very cool. And subscribe even. That's also very cool. Thanks for watching and I will see you later.